Welcome back 10th standard. We are doing exercise 5.2. We are left with a few questions. Let's continue with those. The first question that we have to do now is question number 12. Two APs have the same common difference. The difference between the 100th terms is 100. What is the difference between their 1000th terms? So let's start by considering two different arithmetic progressions. We are being given that there are two arithmetic progressions, their common difference is same. So we will represent these arithmetic progressions in different ways, but we will take the common difference same. I'm writing this side by side. I've got first arithmetic progression, I've got the second arithmetic progression. Now, since we have two different arithmetic progressions, I'm going to represent them in a different way. So for the first arithmetic progression, let the first term as A, the common difference as D. Then if I want to write down any term in general, we call it the nth term and it is represented as an. Now remember, if I've taken the first term as small a, lowercase a, I have taken the nth term also with small a. So these need to be same, a and a. The first term and the nth term should have the same way of writing a. This will be given by a plus n minus 1 multiplied with the common difference. Now let's take the second arithmetic progression. Let the first term, now we don't know what the arithmetic progressions are. The first terms may or may not be same. So as for now, I'm considering that the first term is different. This has a different first term and the second arithmetic progression has a different first term, and I'm taking a different variable to represent that. You could use a different variable. I'm using a as such, but I've taken it capital A. Now we have been given that the common difference is same, so the common difference for the second arithmetic progression will also be D. So this is same, this is given to us. And then writing down the nth term, general term for the second arithmetic progression. Now this will be represented with capital A and n in the subscript. This will be the first term, A plus n minus 1 multiplied with D. Now after you've written this, let's move on to what they have given in the question. We have been given that the difference between the 100th terms of the two APs, the 100th term of the first arithmetic progression and the 100th term of the second arithmetic progression, the difference between them is equal to 100. So you can write the difference in any order because we don't have the terms. We don't know which arithmetic progression is bigger or smaller. So I'm just writing down first arithmetic progression, the term from the first progression minus the term from the second progression. So 100th term from the first arithmetic progression, it is written by small a. 100th term from here minus the 100th term from the second progression, this will be written using capital A. And the difference is 100. Now let's use the formula for these. The 100th term will be A plus 99 times D for this one, and minus for the second arithmetic progression using this formula, A plus 99 times D. The common difference is same, only the first term is different. Solving, opening the brackets and changing the signs. The term containing D gets cancelled. This is not cancelled. So we are left with A minus A equals to 100. So as for now, this is what we obtain from what's given to us. Considering the difference between the 100th terms, this is what we get. Now using what was given, that the difference between the 100th terms of the two arithmetic progressions is 100, this is what I have obtained. Now I'm going to find out what they're asking. They are asking to find out the difference between the 1000th terms. So if I write down the 1000th term for the first progression and I write down the 1000th term for the second progression, what will be the difference? So this will be given by A 1000, the 1000th term from the first progression, minus capital A 1000. This is the 1000th term from the second arithmetic progression. Now apply the formula to find out the 1000th term. This will be A plus 999 times D, the formula for AN. So AN is given by A plus N minus 1 times D. If I write down A 1000, this will be A plus 1000 minus 1 times D. This will be A plus 999 D. So I'm not solving it. You can do this in rough, or you could write here if you want. Same way for the second progression, it will be capital A plus 999 times D. Solving. From here, the terms containing D, they get cancelled because the common difference was same. We have used the same letter D. That's why these terms have cancelled. We are left with A minus capital A, and the value for this can be written using first relation. This is 100, and that's what the answer is. The next question is question number 13. It's a very important question. The type is very important. Question number 13 and question number 14 are similar. Question number 13 says, how many 3-digit numbers are divisible by 7? We have to find out how many 3-digit numbers are divisible by 7. So first of all, we start by looking at the 3-digit numbers. So I'll just do it in rough first and then we will write down properly. So if you look at 3-digit numbers, the smallest 3-digit number is 100. Before it we have 99, which is a 2-digit number. So 3-digit numbers start from 100, then 101, 102, and they go up to 999. After this we have 1000, which is a 4-digit number. So these are the 3-digit numbers that we have. This is the list of 3-digit numbers. Out of these 3-digit numbers, if I write down which numbers are divisible by 7, so let's write that down. Remember, we have to pick from this list 3-digit numbers divisible by 7. So starting from 100, 100 is not divisible by 7. 101, it's not divisible by 7. 102, you can do the division in the working column if you want, and you can find out for yourself. If you keep going one by one, what you will see is that the first 3-digit number which is divisible by 7 is 105. 100, 101, 102, 103, 104, they are not divisible by 7. So when you reach 105, it will be divisible by 7. After that, the next number that's divisible by 7 is 112, then 119, and so on. You can keep writing, and we want to know which will be the last number in this list. From this list, which will be the last number which is divisible by 7. So you can start going backwards from here. So 999, you can divide it in the working column whether or not it's divisible by 7. Then 998, 997, you can keep trying and then find out which will be the last 3-digit number divisible by 7, and you will observe that it is 994. So these are the 3-digit numbers which are divisible by 7, and we want to find out how many numbers are there in this list. Now the first thing we want to check here is this an AP? Because the chapter is based on arithmetic progression, all the formulae that you have are based on a sequence which forms arithmetic progression. So you want to first of all check this, that this list should form an AP. So if you want to check, that's quite obvious because this is a list of multiples. This is a list of the multiples of 7. And the multiples always form an AP. You can see they are increasing by 7. So yes, this is an AP. And when we have an AP, we want to write down the first term and the common difference. So the first term here is 105, and the common difference represented by D. Take any two consecutive terms and subtract them. So I'm taking the first and the second one. 112 minus 105 is 7. So we have the first term, we have the common difference. Now we can focus on what we want to find out. Now we want to find out how many numbers are there in the list. So this is the list that we have. We want to find out how many numbers are there in this list. So we want to find the number of terms in this arithmetic progression, because this list forms an arithmetic progression and the numbers in the list are referred to as the terms of the AP. So we want to find out how many terms are there, and we have already done a question like this. This is now similar to question number 5, where we find out the number of terms in a finite arithmetic progression. We know from where the list starts, we know at what number the list ends. We want to know how many numbers are there, how many values are there in this list. So let the number of terms be n, then the last term will be an. Once again, if I assume that if I say there are 15 terms, the number of terms is 15, then the last term will be a15, 15th term. So since I don't know how many terms are there, I've taken it as n. The last term will be an. But if I look at the list, I know the value of an. The last term is 994. Now this is what my equation will be, and I'll be using it to find out n. Using the formula for the nth term, it is a plus n minus 1 times d equals to 994. Use the values of a and d as I have obtained. Now it's simplification to find out the value of n. Take your time. So from here you can see that there are 128 terms in this list. And these terms in the AP are actually the 3-digit multiples of 7, or 3-digit numbers divisible by 7. So this is your answer. Now similar to this, we have the next question where we are talking about the multiples of 4. Remember, the multiples of a number are same as the numbers which are divisible by that number. For example, here in this particular question, when we say the numbers divisible by 7, we can also say that the question is based on multiples of 7. So if you look at the next question, they're talking about multiples of 4 between 10 and 250. The way you have to do next question is exactly same to question number 13th. Question number 14th, how many multiples of 4 lie between 10 and 250? So let's start by listing down those multiples. Multiples of 4 between 10 and 250. Now first thing you want to note down here is, because they have used the word between, these two values will be excluded. You are not going to count these between. You will only look at the numbers between these two. 10 and 250 will not be included here. So if I just write down after 10 starting from 11, so starting from 11 and going up to 249, I have to list the numbers which are multiples of 4, or with the numbers which are divisible by 4. So starting from 11, 11 is not divisible, 12 is. After 12 we will get 16, then 20, and so on. And from 250 we don't have to count 250. The last number that I will be taking is 249. It is not a multiple of 4, so we look at a number before that, 248. Yes, 248 is divisible by 4. So this is the list of numbers which lie between these two, and they are the multiples of 4. Now again, first thing you want to check is it an AP? We have to find out how many terms are there, how many multiples are there in this list. But before that, we want to find out whether this list forms an AP or not. So yes, this is an arithmetic progression, and every time you have an arithmetic progression, you want to write down the first term and the common difference. So the first term in this arithmetic progression is 12, and the common difference is 4. You can write this directly also, because you know that you're talking about multiples of 4, so the values are increasing by 4. So now we have A and D. We want to find out the number of terms in this arithmetic progression. Again, I will proceed like question number 5 by assuming let the number of terms be n. This means the last term will be an, but from the list an is 248. Now using the formula for an, a plus n minus 1 times d equals to 248, using the values of a and d now. Simplifying and obtaining the value for n. So n comes out to be 60. There are 60 terms in this arithmetic progression, which means there are 60 multiples of 4 between 10 and 250. This is from where we started, the multiples of 4 that lie between 10 and 250, and we have actually found out how many multiples will be there. Let's look at the next question, question number 15th. For what value of n are the nth terms of two arithmetic progressions as given equal? So you have been given two arithmetic progressions. I want you to compare this question with question number 12th, because in question number 12th also they were talking about two arithmetic progressions. Now the questions are similar because they are talking about two arithmetic progressions. There were two arithmetic progressions in 12th question. There are two arithmetic progressions in 15th question. But there is a big difference here. In question number 12th, the common difference for the two progressions was same. But in question number 15th, if you look at the arithmetic progressions given to you, you will realize that not just the first term is different, but the common difference is also different. So these are the two arithmetic progressions given to us. This is the first arithmetic progression. It starts with 63. Second term is 65, third term is 67, so on. In the second arithmetic progression, the first term is 3, second term is 10, the third term is 17, and so on. So whenever we are given the arithmetic progressions, we want to write down the first term and the common difference. Now I'm going to write down the first term and the common difference for both of these. So the first term for the first progression, I'm representing it with small a. This is 63, and the common difference, I am representing it with small d. Difference between two consecutive terms, this is 2. Moving to the second arithmetic progression, I will be taking a different representation here because the first terms are different. So the variable will also be different. I'm representing with capital A, like question number 12. So the first term here is 3. Looking at the common difference for the second arithmetic progression, difference between two consecutive terms, this is 10 minus 3, which is 7. Now the common difference is also not same, it's different. Here it's 2, here it's 7. But in question number 12, the common difference was same. We represented it as d for both progressions. The first terms were represented with small a, capital A in question 12. Common difference was d for both in question number 12. But in this question, the first term is also different, small a, capital A. The common difference is also different. So the common difference is also different. So I'm representing the common difference for the first progression with small d, for the second progression with capital D. So this is something which you want to remember, that we have taken different representation here. Now let us focus on what the question is. They are saying that the nth terms should be equal and you have to find out the value of n. So if we are talking about nth term, let's write down the nth term. The nth term for the first progression represented by small a. Using small a and small d, n is same. This is the nth term. And same way, for the second progression, let's write down the nth term. Now I'll be using capital A and capital D. Now according to question, an is equal to an. The nth term of first progression, nth term of the second progression should be equal, and we want to obtain the value of n. Let's put the values and solve. Using values of a and d from here. Capital A, capital D from the second progression. I had written by mistake, this should be capital D here, capital A. Use the values and now solve. N comes out to be 13. So this means the 13th terms of the given arithmetic progressions are equal. Now what this means is, if we had written the terms in the progressions given to us, at 13th place we will get the same value. If I had to check this, now quickly looking at the first arithmetic progression and the second arithmetic progression. First arithmetic progression is 63, 65, 67. Let's write down a few more terms. Increasing by 2, adding 2. So I can obtain as many terms as I want. So I've written 13 terms. This is A1, A2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the 13th term for the first progression. Now let's write down for the second progression. The second progression is 3, 10, 17, adding 7. again, if you just look at this, this is the first term, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12, 13. This is the 13th term, and what you can see is that the 13th term for both the observations, both the arithmetic progressions, is same. This is what we wanted to find out, at what place we get the same answer. And we have not done by listing the values, because it could have been difficult if we did not obtain the values as soon as we have done here. So it's better to work with the formula.